Hello guys, welcome again to this video. So what we did in the last chapter and the previous one, that is two videos have been done on gamma function, and you might now realize that the gamma function has its own properties which are specific to natural numbers and different for real numbers, because for real numbers we could not actually express it in terms of elementary functions like that of the natural numbers. But what we can do is we can always use the recursive definition. So recalling from the previous two chapters, results proved are as follows. Results already proved are gamma of n is equals to n minus 1 factorial for all n belongs to natural numbers. So this is true irrespective of irrespective of the n basically. So n can be any natural number and gamma of n would still give you n minus 1 factorial. In a similar way, gamma of n plus 1 would give you a n factorial. Number 2, so gamma of s is equals to 0 to positive infinity x to the power s minus 1 into e to the power minus x dx, and this is true for all positive real numbers. So we did not yet get to the part where we have where we do have like negative fractional numbers, and that is also a thing. Just understand it for now that negative fractional factorials are also defined, while negative integer numbers for gamma function are basically infinity. So number 3, what is that we found that gamma s is equals to s minus 1 into gamma s minus 1 for all s belongs to real plus. Okay, and just understand that this is also true for complex numbers. S belongs to z with a 0 here, because we do not include the number 0 inside the gamma function, because that is basically negative infinity. Okay, right. So this would be our summaries for finding whatever we did in the previous lections. Now let us understand a few properties. And therefore, so since that can be evaluated for natural numbers, and therefore what we have is gamma, let me write down a few values. Gamma 1 is 0 factorial, which is 1. Gamma 2 is just 1 factorial, which is also 1. Gamma 3 is just 2 factorial, which is 2. Gamma 4 is just 3 factorial, which is 6. Gamma 5 would be 4 factorial, which is 24, and so on. So this would be some of the special values, and you can go on and on. Our goal eventually would be to find the value of gamma of 1 by 2, and we would try to resort to different methods in order to find this, but yes, this would be our general way of finding how to do this exact function. Okay, right. Now what we tend to do in terms of learning gamma function is that we would also learn the beta function in relation to it. Now, let us evaluate a few integrals in relation to this. So number 1, 0 to positive infinity e to the power minus x cubed dx. So previously, if you remember, we had encountered integrals of the same type where the power of x may have been different, but it does not matter because they are of the same kind. But now you do know that this is called the gamma function, and previously what we would have done is we would have used IBP every time, and we would have to use it 3 times to get to the actual answer. But now what you do know is you can always express it like this: 0 to positive infinity. You have to write the power of x as something minus 1, that is 4 minus 1 for this case, dx, and this would be simply equals to gamma of 4, isn't it? And you do know that gamma of 4 is 3 factorial, and this should be equals to 6. So this integrals become quite a lot easier when you do understand the fact that the functions here this integrand can be really expressed in terms of gamma function. So you do not need to use IBP or any kinds of method again, because you just have a standard formula for evaluating this kind of integrals. Now let us do a more general one. So e to the power minus ax x to the power n dx for a greater than 0. So the solution to this one would be, firstly, we do not have the form of gamma because it should only be e to the power minus x, right? So obviously, since it should be only e to the power minus x, we have to substitute here. So which means it will be dy equals to a dx, right? And x should be equals to y by a. And the limits would not change because the limits are basically 0 to plus infinity. So just scaling the variable by a constant a would not affect. So therefore 0 to positive infinity e to the power minus ax into x to the power n dx would be equal to 0 to positive infinity, and this e to the power minus ax would become e to the power minus y, x would become y by a whole to the power n, and dx would become dy by a. As you can see, we have put all the values of x in terms of y. Now this would give us 0 to positive infinity e to the power minus y, y to the power n dy, and there would be a multiplication of 1 by a to the power n plus 1, and this would be 1 by a to the power n plus 1, 0 to positive infinity. What we can write is y to the power n plus 1 minus 1 e to the power minus y dy. As you can see, the integral is in the form of gamma function, so we can write it as 1 by a to the power n plus 1 gamma of n plus 1. So to summarize, what we have is 0 to infinity e to the power minus ax x to the power n dx is simply equals to gamma of n plus 1 by a to the power n plus 1 for a greater than 0 and n greater than 0. This is our result. So now you know the general formula for finding this kind of integrals, and this can be used. And if you were to find out only for using it as the natural numbers n, you can also write it as n factorial by a to the power n plus 1, which is also true. Okay, so now let us understand how to find gamma function here and how to find some of the identities, but we shall do that in the next video, where we would be looking forward to find the value of gamma of half. We will give Euler's of reflection formula as well, and then we shall understand how to do that from there on. Right. Thank you for watching. So please download the Breatter Maths app, which is given in the description. It is a mathematical app where you can find all the necessary statistical calculators like chi-square calculator, one variable means, population means, t-value, and much more. You can also find calculus related calculators like integration, derivatives. There is a section where you can find what's coming up next. There is a section completely devoted on mathematical notes, where you can find notes on probability, statistics, calculus, and many more are there to come. In those notes, we have already explained all the examples, all the problems and theory, and we are just covering the video lessons and solutions of those here. You can check that out. Also, you can see the video solutions in a separate section where you can understand and give a feedback on what to expect next. You can ask for a problem, you can ask for a theory section as well. So please do check it out, and also do subscribe to Breatter Maths app and also its YouTube channel.